Hello, welcome back to Learn Physics. In today's topic, we are continuing with the previous year question paper, and in last video we did tell the 20th question. So today we are continuing with the 21st question. Why is it difficult to detect the presence of an antineutrino during beta decay? Define the term decay constant and of a radioactive nucleus and derive the expression for its mean life in terms of decay constant. Okay, so first we should answer why is it difficult to identify antineutrino. What is the reason? Say interaction, weak interaction with the matter. It has very high penetrating power. These are the two reasons we can't identify antineutrino while beta decay happens. Okay, it has very high penetrating power, and the second one is it won't interact with matter. If it is interacting with matter, then only we can easily identify it. Okay, so the next is define the term decay constant. What is the decay constant? It is the reciprocal of the time duration in which the radioactive nuclei becomes 1 by E times the initial radioactive nuclei. Okay, it is the reciprocal of the time duration in which the initial radioactive nuclei become 1 by E times the initial radioactive nuclei. That is called a decay constant. Okay, it is 2 equals 1 by lambda. That is the expression for mean life in terms of 2 equals 1 by lambda. That is decay constant and mean life expression. Okay, that and all derivations and all we did that. State two distinguishing features of nuclear force. It is short range force. It's an attractive force. It does not depend on charge, and it is the strongest force. So these are the any two only it is asked. Any two you can write down. Draw a plot showing the variation of potential energy of a pair of nucleons as a function of their separation. A pair of nucleons and potential energy. Distance between the pair of nuclei and what is that potential energy? What is that graph? See, this is the distance in Fermi, and this is potential energy in electron volt we are representing. See, here we are giving it as 0, here it is minus 100, and this is plus 100. So it is decreasing, and after that remaining constant. Okay, so this is R0. R less than R0 will be repulsive force, and R greater than R0 will be attractive force. Okay, so these are this is the diagram. Okay, potential energy and the distance between the nucleons. Okay, the graph will be like this. Okay, R less than R0 means it's repulsive, and R greater than R0 will be attractive force. Okay, so the next one is a triangular prism of refracting angle 60 degree is made of transparent material of refractive index 2 by root 3. A ray of light is incident normally on face KL as shown in figure. Trace the path of the ray as it passes through the prism and calculate the angle of emergence and angle of deviation. So here this is the prism KLM. This is PQ which is falling. It is 90 degree. It is given, and here when it is approaching here like this. Okay, here This is the normal. This is the normal. Okay, so this is 90 degree. It's given like this is 60 degree. So here 90. What is this? 30 degree. Right. This is the normal which we are getting. So the rest of the things are 60 degree. So whether it is falling at the critical angle or not, we should find out, right? So what is the formula? N is equal to 1 by sine C. N is given like, what is the refractive index as? 2 by root 3. 2 by root 3. So 2 by root 3 equals 1 by sine C. So sine C equals root 3 by 2. So C is 60 degree. Critical angle is 60 degree. But here the ray of light is incidenting at the critical angle. Okay. So at critical angle, if the ray of light is passing, what will happen? It will be grazing through the surface of separation, isn't it? So the angle of refraction will be 90 degree over there, right? So it is passing through like this. Angle of refraction, or we can say angle of emergence, will be 90 degree. So here, since it is falling at the critical angle, angle of emergence will be 90 degree. Okay, so here we should find out angle of deviation also. What is angle of deviation? I plus E equals A plus delta. This is the formula. What is I? I is 90 degree. See, it is passing through the, I is 0. It is passing through the normal, so angle of emergence you are getting it as 90 degree. That is equal to angle A plus 30, this is delta. So delta we will get it as 30 degree. This is angle of deviation. Okay, so deviation is 30 degree, emergence is 90 degree. Okay, clear? So next is 23rd question. Prove that in a common emitter amplifier, the output and input differ in phase by 180 degree. How we will find out the output and input differ in phase by 180 degree? How we can prove that? Because that one is in this voltage amplification factor, AV. What is the value of AV? Minus beta into RL by R. Isn't it? This was the formula which we are deriving for our voltage amplification AV. So AV equals minus beta into RL by Ri. In that, the negative sign indicates that it is 180 degree out of phase. So what you should do here, you should first derive the formula AV equals minus beta into RL by Ri. Draw the common emitter circuit and output voltage divided by input voltage, isn't it? There's voltage amplification means it is output voltage divided by input voltage gain, not amplification. Voltage gain equals amplification factor into RL by Ri. How we are getting this one? Output voltage gain equals output voltage divided by input voltage. So here we are taking the output voltage is output current into resistance. Okay, there only the output resistance, there only we are getting beta also, input current into input resistance. So here we are getting the value of the final expression will be like this. Okay, that it is there in the textbook. As such, you can write down voltage amplification, voltage gain equals output voltage divided by input voltage. While solving that, we will get the expression minus beta into RL by Ri. That shows that it is 180 degree out of phase. Input and output voltages are at 180 degree out of phase. Okay, then in a transistor, the change in base current is given by 30 microampere produce a change of 0.02 volt in the base emitter voltage and a change of 4 milliampere in the collector current. Calculate the current amplification factor and the load resistance used if the voltage gain of the amplifier is 400. So what are the given data? Say change in base current, that is delta IB, that is equal to 30 microamps. produces a change in voltage in the base emitter voltage, change of 0.02 volt in the base emitter voltage. Base emitter means it is input, okay, is 0.02 volt, and a change of 4 milliampere in the collector current. So delta IC equals 4 into 10 to the power minus 3 ampere. Calculate the current amplification factor. So current amplification factor means output current divided by input current, which is the output current. Collector current is the in a common emitter. Emitter is common. Okay, so base is the input and collector is the output. Okay, so output current is delta IC divided by delta IB. So we will get it as 4 into 10 to the power minus 3 divided by 30 into 10 to the power minus 6. Okay, this one you can solve and find out the value of beta, current amplification factor. And the load resistance, if the voltage gain of the amplifier is 400. See, voltage gain is given. Voltage gain is given as 400. Load resistance, RL we should find out. How we can find out the RL? See, here we have beta we have with us and AB we have, but RI we don't have. For that we are getting the voltage and current. So using this voltage and current, find out the resistance. Okay, that input resistance, that is R, that resistance you can substitute it over here and find out the value of AB, find out the value of RL. Okay, load resistance AB into RI divided by beta. Okay, here AV is given in the question and beta also we found out the answer, and RI, from here you will be getting the value of RI. V equals IR. Using that formula you can find out. Okay, can you do that? So next is 24th question. Show variation of resistivity of a conductor and a typical semiconductor as a function of temperature. Resistivity in a conductor as increase in temperature. As increase in temperature, temperature increases, what will happen to resistance in the case of a conductor? As temperature increases, see the resistance. First one, it will, the graph for a conductor. Resistance, the same thing only for a resistivity also. Okay, but in the case of a semiconductor, what will happen? As temperature increases, the resistivity decreases, isn't it? So here this is for a semiconductor resistivity and temperature. Here for a conductor, resistivity and temperature. Using the expression of resistivity in terms of number, density and relaxation time between the collision, explain how resistivity in the case of a conductor increases while decreases in a semiconductor with the rise of temperature. So there itself they are telling as temperature increases, in the case of semiconductor resistivity decreases. So how we can explain that using this expression rho equals m by n e square 2, right? So as temperature increases in the case of conductor, as temperature increases, what will happen? Relaxation time will be decreasing, isn't it? Relaxation time decreases. As relaxation time decreases, what will happen? Resistivity increases. Okay, but in the case of a semiconductor, what will happen? As temperature increases, the number density of electron, more electrons will jump to the conduction band. So number density increases, therefore rho will decrease. So here in the question also explain how the resistivity in the case of a conductor increases and while it decreases in a semiconductor. Rho is decreasing in the case of semiconductor, okay, with the rise in temperature. Okay, clear? So rho equals m by n e square 2. Okay. So next is 25th question. Derive an expression for induced EMF developed When a coil of n turns, an area of cross section capital A is rotated at a constant angular speed omega in a uniform magnetic field B. Okay, we should find out the derive an expression for EMF. EMF we should find out. Okay, for that how we can find E equals minus d phi by dt, isn't it? Phi equals NAB cos omega t. Okay, while the EMF is equal to minus NAB omega sin omega t. Like that we will be getting cos of minus theta minus sin theta. So it will be NAB omega sin omega t. This is the expression. A wheel with 100 metallic spokes, each 0.5 meter long, is rotated with a speed of 120 revolutions per minute in a plane normal to the horizontal component of Earth's magnetic field. If the resultant magnetic field at that place is 4 into 10 to the power minus 4 Tesla and the angle of dip at the place is 30 degree, find the EMF induced between the axle and the rim of the wheel. Okay. Number of spokes is given as 100 and length is 0.5 meter, is rotated with a speed of 120 revolutions per minute. What is that? Its frequency. Number of revolutions per minute is given as 120 revolutions per minute divided by 60. If you are doing, you will be getting in hertz, revolutions per second. Okay, so 2 revolutions per second. 2 second to the power minus 1. That will be the frequency. Okay, then in a plane normal to the horizontal component of Earth's magnetic field, if the resultant magnetic field is given as B equals 4 into 10 to the power minus 4 Tesla and angle of dip delta equals 30 degree, we should find out EMF. What is the formula for finding out the EMF? Half B omega L square. This is the expression. So here we have B we don't have, horizontal component we should find out, and omega we don't have, L we have. So here half into BH, how we can find out? B cos delta. Okay, omega how we can find out? 2 pi into nu. L is there. So now all the components we have. So half equal into 4 into 10 to the power minus 4 into cos 30, 2 pi into 2 into L square is 0.5, the whole square. So while you are solving this, you will be getting the answer. Here identifying the formula and substitution is very important. Okay, clear? So the next one is derive the expression for magnetic energy stored in an inductor when a current I develops in it. Hence, obtain the expression for magnetic energy density. Energy density, how we can find out energy density? Energy density equals here energy density. We should find out the energy density, that total energy divided by volume. Energy density will be equal to total energy divided by volume. Total energy, how we can find out? Total energy will be equal to the work. What is the total work done? In an inductor, what is the work done? Half Li square. That one we are already learning, right? So here half Li square divided by volume you should find out. Okay, half Li square, that one you should derive first, divided by I. That one you should do. Okay, clear? So these are some of the questions in this question paper, and in next day I will be coming with the rest of the questions in this question paper. And now hereafter I will be doing a revision for your each chapter. Okay, and along with that first your numericals, solved examples, we will explain the solved example, whichever I am feeling it is good. It's it's repeatedly asked questions, like that one kind of revision. So if you are reading once your revisions are getting over, then after that just for a just reminding your theory portion once more, and we will do some numericals as well as some theory portions also. Okay, it's not a detailed explanation, like that we will do. Okay, because some of the students asked in such a way, so I thought, so this will be a mixture of from all the chapters. So now I can go for each one chapter and some of the questions related to that chapter. Okay, so I hope it is useful for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.